So, what we have here is a hollow sphere of centre C and radius r and a small marble rests at the lowest point inside the smooth sphere. The marble is then projected horizontally with this speed here. Find the angle at which CQ makes with the downward vertical. Once again, downward vertical, guys, specifies that it makes it above the halfway point. So, technically speaking, its start off point is here, and then its end point is up there. Okay? Makes it the downward vertical at the moment when the marble moves away from the inside surface. So what happens when it stops moving on the inside surface? The R value is going to turn to 0. Now, odd one about this one is in the last question you were on the outside of the sphere. This question you're on the inside. So it's like doing a loop-to-loop. You've seen people like motorbike riders who can like go all the way up and around if they're carrying enough speed. That can actually happen. And you'll never lose contact with the surface. Okay? What we have here, guys, is as I said, basically it's like swinging a bucket of water. The water will stay in contact with the inside of the bucket if you carry enough, if you have enough speed. If you don't have enough speed, it will reach a point where it will start to drop off. Okay, so in this question, we're told that we haven't got enough speed to do the full circle, and that at one point it's definitely going to drop off. Okay. So what we're going to do is our usual system. We're going to have a formula that's relating FC, or centripetal force, to mv squared over r. We're going to have a second system which has our our potential energy at point 1 plus our kinetic energy at point 1 equals our potential energy at point 2 plus our kinetic energy at point 2. Okay. So, inside surface point. Okay. It says the downward vertical, okay? Can anybody tell me what downward vertical means instead of upward vertical? So I'm currently having an angle up the upward vertical. The downward vertical, however, would be the downward vertical is that. So this angle here is an angle with the downward vertical. However, if I want an angle with the upward vertical, I go this direction up here, and then I say, oh, it's this angle. So everybody knows the difference between downward vertical and upward vertical now? Okay. So, downward vertical. So apparently loses contact here. Okay, so let's begin. First of all, what force is acting straight along the radius? Can anybody tell me? A force that is acting straight along the radius. Huh? No tension in this question. You're just on the inside of a sphere. The reaction force, the ground is what's keeping it in play. So the ground, the reaction force acting directly inwards. Everybody right with that? Now, what force acts directly down? mg. Alternate angle it. Theta here. Now, where's our theta going to appear this time? Sorry? Our theta is going to be here this time, isn't it? I'm going for opposite angles, but yeah. Or you might see it as actually you see it as corresponding. I see where you see it. I see it as opposite. You see it as corresponding. Yeah, same thing. Okay. So this is going to be mg sine theta on the way down, and on the way out it's going to be mg cos theta. Is everybody right with that? Now, find the angle. We don't know what theta is. Find theta. And find the angle which makes it downward at the moment when the marble moves away from the inside the surface. So r will equal 0 at one point. Okay. So guys, FC equals mv squared over r. Let's start working on that one there. Okay, so what is driving it towards the center of the circle? Anything driving it towards the center of the circle? R. Anything driving it away from the centre of the circle. mg cos theta. You can see that it works in the opposite direction. Okay. mv squared over r, safe as usual. Cross multiplied by small r. R, big R, minus mg r cos theta equals mv squared. Okay. Star that one, save it for later. Okay, question part 2. We're specifying the bottom as terra firma. There is no potential energy at this point. So your P1, guys, your potential energy at point 1, anybody? You're starting here and you're finishing here. So what do we say it's going to be? 0. Your kinetic energy is a half mu squared, where u is your initial velocity. What is u? U is 7 over 2 gr. Therefore u squared is thus 7 over 2 gr. Okay. What does it equal? How high did we get? Now here's an interesting one. This is a difficult one to do. Okay, so I'm going to get rid of all this business here for a minute. Okay. Now remember what I told you. We're looking for potential energy, PE2, potential energy at point 2. It's mgh. It's mass by gravity by some heights that we aren't sure about those yet. Now here's what you do. You write the particle here. See the black dot? That's where you are. The other black dot is where you started. You bring your black dot directly across. You now want to find out what is this red distance here. Well done. Okay. So what we have here, guys, is I'm going to find out what the green distance is. I'm going to find out what the green distance is, if everybody's alright with that. This is r, because it's the radius. It means the green distance down here is the adjacent of that right angle triangle, which makes it r cos theta. Yeah? Now, what we know is that the green line plus the red line added together give you r. So if I call the red line x, it's going to be x plus r cos theta has to equal the full radius r. Therefore x equals r minus r cos theta. R minus r cos theta. That makes sense? Okay. Next part after that, guys, is our kinetic energy. How much speed are we carrying at this point? Anybody care to tell me? Use the formula. Half mv squared. Do what we always do. A quarter mgr equals oh it is, sorry, I took that as a 1. 704 mgr, that looks like a T. 704 mgr equals mgr minus mgr cos theta plus a half mv squared. Bring the mgr over your side, it's now going to become 3 over 4 mgr. That's going to be plus mgr cos theta equals a half mv squared. You know my whole thing, I like to get the mv squared isolated. We'll cross multiply by 2, 3 over 2 mgr plus 2 mgr cos theta equals mv squared. The other mv squared is up here, isn't it? See the r minus mg cos theta? So all I have to do is write that underneath. R minus mg cos theta goes 3 over 2 mgr. Did I forget that time? I did. It's this equation here, isn't it? Is the one I'm looking for. So you're right, the small r has to be there. So small r here, small r here. So that's what I was actually using, was this equation here. Okay? So r by big R minus mgr cos theta, then we're nearly done. 2 mgr cos theta. Bring the mgr cos theta, all these small r's cancel. They're going to go off anyway. Then we're going to get 3 over 2 mg. I'm going to bring this over the other side actually, and I'm going to get a minus 3 mg cos theta. And then we're going to figure out that this here is r, okay? Now what do we say about r at the point where it leaves? Equals to 0. Now guys, wasn't there something a bit weird about this question that we used the downward vertical? But logic would dictate that it will still be in contact, won't it? Would you agree with that? Like it's like you ever roll something on a semicircular surface, it stays like just like this, like it'll just keep rolling. It'll always be in contact with the bottom hemisphere. It's when it reaches the top hemisphere that's when it stops making contact. So this whole system was like, why did we use the downward vertical? Why didn't we use the upward vertical? Which makes sense. Well, the system's going to auto-correct itself. And what we're going to get is, we're going to get an angle that's bigger than 90 degrees. And it's going to correct itself. Okay, so let me show you. So, yeah. So what we're going to get is r equals 0. Then we're going to get minus 3 mg cos theta equals 3 over 2 mg. 3 mg is just take a hike. Minus 1. Start right, minus 1. So minus 1 goes down, so you're going to get minus a half equals cos theta. Cos inverse minus a half, anybody? 120 degrees. So what this means is that this angle here is not, so here it is at 90 degrees. And then it goes up yet another 30. So it's 120 degrees in here, which is technically 60 degrees against the downward vertical had you used the previous system. So whether you use the upward vertical or the downward vertical, you're going to get the same answer. Okay lads, well done. One more thing. Through what vertical distance has the marble travelled to this point? Really quickly does it. Okay? Remember what we said earlier? It travels 120 degrees, that's 30 degrees. So the distance from, excuse me guys, the distance from here to here is r. The radius is r. So we just have to find out what distance is it from here to here. R sine 30. What is sine 30? It's a half. So it's r plus a half r is how far it's risen. R plus a half r equals 3 over 2r.